Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the last point of the Unit 4 named as the block diagram and explanation of the UPS. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to start the Unit 5th of this subject named as Oscillator. Let's start our today's topic. What is an oscillator? An oscillator is an amplifier that acts as a generator by using positive feedback concept. That means the oscillator is an electronic device which acts as a generator and which uses the positive feedback network. And the oscillator basically is an amplifier. Okay, we know that every electronic circuit requires input, then it gives us output. Without input we cannot obtain the specific output, but the oscillator is an electronic component or electronic device which does not require input. This is the very important thing about oscillator, is that the oscillator circuit does not require any input signal. It gives us output by using the feedback network. Okay, by using the feedback network, and this feedback network or this feedback element gives supply to the amplifier. Okay, this is the basic diagram of the oscillator. I hope you all understand the concept here. The oscillator is basically as an amplifier and is uses a positive feedback network, and oscillator does not require any input signal. This is the most important statement here, that the oscillator does not require any input signal. It produces an output waveform of constant amplitude and constant frequency up to several hertz as required. The output depends on the values of the component. Generally in oscillator circuit, the resistors and capacitors are used. In other type of oscillators, the inductors and capacitors also used. Okay, that means the output waveform, that means the output of the oscillator is depends upon the values of the component, that means the values of the resistor, capacitor, inductor, etc. It produces output oscillations as long as it connected to the DC power source. That means the oscillator is an electronic circuit which does not require any specific input signal. It produces its oscillations by the DC power source. As long as the DC power source is connected, the oscillations are produced. When we disconnect this DC power source, then the oscillator stops working. This is the basic concept about the oscillator. Let's see the basic block diagram of an oscillator. This is the basic block diagram of an oscillator, in which we can see here there are three blocks. First one is oscillatory circuit, second one is amplifier, and third one is positive feedback network. Note here that there is no specific input signal given to the oscillator circuit. Okay, let's see details about this block diagram. Here the feedback network is the frequency selective circuit. Okay, this is the feedback network. I hope you all know about what is meant by feedback. Let's see once again. The feedback means the fraction of the output is given to the input again. This is known as feedback. Okay, that means some part of output is taken and this part is given to the input of the circuit. This is the feedback concept, and here in oscillator generally a positive feedback network is used. The oscillatory circuit employed before the amplifier circuit in the above figure can be LC tank circuit or RC network or quartz crystal. Here this oscillator circuit generally may be a LC tank circuit. LC tank circuit means there is a simple combination of inductor and capacitor like this. Okay, that means inductor and capacitor connected parallelly to each other. This type of circuit is known as The LC tank circuit or the oscillator circuit may be resistor and capacitor type circuit. Okay, that means, or the oscillator circuit may be any quartz crystal. I hope you all understand the basic idea about the oscillatory circuit. Now let's see the next point. Let's see the basically working of this block diagram. Here the amplifier basically changes the DC voltage provided by the supply into the AC power. We know that the basic function of the amplifier is to amplify the input signal, but here the input signal is not present, but it is connected with the DC power supply. Hence this amplifier converts this DC voltage into the specific AC power. Okay, this AC signal is given to the tank circuit through a feedback path. That means the whatever the circuit produced by the amplifier, that means the AC signal, this signal is given to the feedback network, and through this feedback network, after its fractioning, it given to the oscillatory circuit. Further, the oscillations of the tank circuit are fed to the amplifier. That means this oscillatory circuit oscillates through this signal and it gives its output to the input as the amplifier. Since the amplifier amplifies the amplified input at its terminal, thus at the output of the amplifier, the amplified oscillations are achieved because of the applied DC voltage. That means here, let's see once again, here what happens, the amplifier amplifies this DC supply and it gives in the form of AC signal. This AC signal is given to the oscillatory circuit through the feedback network. Okay, then the oscillatory circuit use this AC signal as an input and gives the oscillations as the input of the amplifier. Again, this oscillatory input or this output of the oscillatory circuit is amplified by this amplifier, and again its some part or some fraction is given again to the input of the oscillatory circuit through the positive feedback network. This process is continuous, hence we get the oscillations in this form or in this form or in this form. Okay. Here the positive feedback gives the correct phase shift. I hope you all know what is meant by phase shift. Let's see, if this is the input signal, then and the output of the amplifier is similar like this, then we can say here that there is a 0 degree phase shift, okay, or 360 degree phase shift. But if the input signal is like that and the output signal is like that, then we can see here that there is a 180 degree phase shift. Okay, here the positive feedback gives the correct phase shift as we required for the oscillator operation. Now let's see the circuit operation of the oscillator. This is the circuit of the oscillator, in which we can see here that there is an amplifier, a feedback path or a feedback network. Okay, now let's see the operation in detail. Suppose Vi is the input applied at the terminal of the amplifier having gain A. That means this amplifier has the gain A, and initially Vi is applied at the input of amplifier. Also, a feedback network is used. This feedback network has the feedback fraction beta. That means this feedback network accepts the feedback fraction beta here. Okay. The output of the amplifier is V0 and that of the feedback network is Vf. That means, let's see once again here, the input of this amplifier is Vi, gain of the amplifier is A, output of the amplifier is V0, the feedback fraction is beta, and output of this feedback path is Vf. Okay, I hope the terms cleared here. Here beta basically defines the fraction of output which is provided as feedback to the input. Okay, now let's see. Next, initially Vi is applied at the terminal of the amplifier with gain A. So the output of the amplifier we get V0 equal to Vi. We know that we can define the gain of the amplifier, that means the gain of the amplifier, or A equal to output upon input. That means A is equal to V out upon V in. Therefore, here let's see once again, V out upon V in. Hence, we can calculate the value of V0 like V0 equal to A into V in. Hence, we get V0 equal to AVI here. Okay, this voltage is provided to the feedback network. That means the output voltage V0 is equal to AVI. Okay, and this voltage is given to the input of the feedback network. So the signal achieved at the output of the feedback amplifier is given as Vf is equal to A beta Vi, because here the Vf is equal to beta V0 and V0 has the value. Let's see once again, Vf is equal to beta V0, but V0 has the value AVI, hence we get here A beta Vi. This is the feedback voltage. I hope you all understand how to calculate these voltages. If the amplifier and the feedback circuit produces 0 degree phase shift, then both the feedback signal as well as the input signal will be in phase with each other. Okay. Now, when the output of the feedback circuit is provided to the amplifier along with this input, then the signal at the output of the amplifier will be given as, that means here we give the signal Vf is equal to beta V0, but the value of V0 is AVI, hence Vf is equal to A beta Vi. This voltage is given as the input here for the amplifier. Then the amplifier amplifies this input and gives the output V0 equal to A Vi minus beta V0. I hope you all understand this calculation here. Now separate the bracket, we get V0 is equal to AVI minus A beta V0. Now rearrange the terms, we get AVI is equal to V0 plus A beta V0, and we get here AVI equal to V0 1 plus A beta. So we can write the closed loop gain of the oscillator with the feedback G is equal to V0 upon Vi is equal to A plus 1 plus A beta, where A is the gain of the amplifier and beta is the fraction of the feedback. Okay. Now for the oscillator there will be no additional input signal. That means there is no input additional signal, that is the feedback signal Vf must act as the input to the amplifier. So we have magnitude of A into beta is equal to 1. Okay. If the value of this magnitude A into beta is having different values, that means less than 1 or greater than 1 or equal to 1, then the output oscillations produced by this oscillator are different in shapes or different from each other. Okay, so here let's see the final statement of this explanation. The positive feedback network produces 180 phase shift. That means if we use this is the positive feedback, then it gives us 180 degree phase shift, and if the inverting type amplifier, that means if we use here the inverting type amplifier, then here we get 180 degree phase shift. That means total there is 180 plus 180, total 360 degree of phase shift. That means there is 360 degree, or we can say that it is a 0 degree phase shift. I hope you all understand. Let's see once again on the diagram. If the amplifier is used here, the inverting type, that means if the input of waveform is like this, then we get here the 180 degree phase shift. Okay, this is called as 180 degree phase shift, and this is applied as the input of the feedback network. And if we use the positive feedback, then we get another 180 degree phase shift here. That means this waveform is another 180 degree phase shift. That means we get total 360 degree phase shift. That means the input waveform and the output of the feedback waveform is similar in phase. Okay, I hope you all understand this here. This is the very important condition in the Barkhauson criteria. Let's see what is the Barkhauson criteria. The two conditions required to work the circuit as an oscillator are called as Barkhauson criteria for oscillation. That means for oscillation there must be two conditions satisfied. What are these two conditions? Let's see once again. These two conditions are the total phase shift around a loop as a signal proceeds from input through the amplifier feedback network back to the input again. Completing a loop is precisely 0 degree or 360 degree. That means the total phase shift around a loop required is 0 degree or 360 degree. This is the one condition for the Barkhauson criteria. The second condition is that the magnitude of the product of the open loop gain of the amplifier A and the magnitude of the feedback factor beta is unity. That means magnitude of A into beta should be equal to 1. This is the second condition for the Barkhauson criteria. The Barkhauson criteria is very important in this unit. Okay, let's see once again the Barkhauson criteria. The any electronic circuit can be worked as an oscillator if it satisfies the two conditions. The two conditions are that the total phase shift around a loop, that means the total phase shift around a loop should be or is precisely 0 degree or 360 degree. Here the oscillator block diagram is shown, in which here use inverting amplifier and feedback network beta. Here inverting amplifier means it gives the phase shift of 180 degree. This is given to the feedback network, and this feedback network again gives 180 degree phase shift. That means there is total 360 degree phase shift in a loop. Hence the first condition is satisfied here. And second is magnitude of A into B is equal to 1. These are the two conditions for the Barkhauson criteria. In reality, no input signal needed to start the oscillations. In practice, A into beta is made greater than 1 to start the oscillations, and then circuit adjusts itself to get A into beta is equal to 1. Finally, resulting into the self-sustained oscillation. That means practically there is no input signal required to start the oscillations. First of all, we have to make the product A into beta greater than 1, and then the oscillation start. After oscillation starts, then A into beta adjusts itself to the unity or equal to 1. Here are the three conditions is shown, in which when magnitude of A into beta is greater than 1, then we get growing type of oscillations. These are the growing type of oscillations. Okay, when magnitude of A into beta is equal to 1, then we get the sustained type of oscillation. That means it has the constant amplitude and frequency. And if the product of or the magnitude of a into beta is less than 1, then we get exponentially decaying type of oscillations, this type of oscillations here. Okay, I hope you all understand what is mean by oscillator and the very important the Barkhauson criteria. Thank you.